So welcome everyone. I'm really glad you could all join us today. We are going to do a brief attendance poll while I'm talking to you here, so you can answer that to let us know how many people are watching with you today. So today's presentation is being recorded, and the link for viewing I'm going to send out to all of our registrants after the program. It'll be available at the beginning of next week, and if you know somebody who couldn't make it today, please share that with them. So if you haven't signed up for Summer Reading Club, it is dinosaur themed. You should sign up. There's so many fun things happening at the library, and you can come visit us to register, or you can go to our website and there'll be a link where you can sign up for that. We've also got more dinosaur programming happening this summer. You may have heard that we're doing an outdoor movie showing of Jurassic Park in partnership with the Park District. So that will be over on the sledding hill next to the pool. And we have a story walk happening in Artesian Park right now for the picture book Am I Yours, which is dinosaur themed. Today's program is sponsored by the Friends of the Lake Bluff Library, so I'd like to say a big thank you to them for helping us make this possible for everyone today. And we are going to jump into our program here. If you have questions, we're going to hold those until the end, at which point you can post them in the chat, or we'll let you unmute yourselves to ask Steve some questions. So everyone, this is our expert paleontologist, Steve, and he's going to tell us about the rise and fall of the dinosaurs.
Right. Well, thank you, Anna. Thank you very much. And thanks for the invitation to do this and for putting it together. And thanks all of you for tuning in here on a Saturday morning, which hopefully is a nice Saturday morning back home. I'll get to that in a second. It's the afternoon here in Scotland, so it's about 5 o'clock. And you can see it's sunny through the window here, which is a pretty unusual thing, really, any time of the year here in Scotland. And I'm just really excited to talk dinosaurs today. And anybody who's listening to the recording down the line, welcome as well. And hopefully this will be fun and interesting for you. Now, I said it's nice to see a lot of you guys back home. It was a nice day back home. So home for me is not too far from you guys. You can probably tell actually by the background I have here, all my memorabilia of my great love, even more than dinosaurs, of the White Sox, and so far so good, except for all the injuries. Anyway, so I come from Northern Illinois. I come from a town called Ottawa, which some of you may know, and it's Starved Rock area, Illinois River, about 75 miles southwest of Chicago. And I grew up there, went to school there, high school there, and so on. And then I went off to Chicago to go to college, and then I, went into paleontology. And kind of being a paleontologist, as we'll see, is a bit of a globetrotting adventure at times, and so that brought me here to Scotland. So I'm joining you from Edinburgh, Scotland, the capital city of Scotland. For those of you that are soccer fans, a city now that's very excited because the European Soccer Championships, the European Football Championships, as we would say, are starting, and Scotland's in the tournament. So that's what's going on here now. But I'm going to talk dinosaurs today. I'm going to put up this screen share, and I'm going to go into a little bit of a presentation. I'm going to go through it fairly quick because I want to leave time for questions. That's always the most interesting, rather than me just blabbering on. But I will blabber on for a little bit. So I'm going to share my screen, and I think you should be seeing this. Hopefully so. Okay. So the rise and fall of the dinosaurs. That's what I call the talk. I'll tell you why in a second. And again, this is just a bit of a sales pitch for us here in Edinburgh. So the reason I live here now is because I'm a professor at the University of Edinburgh. So my job as a scientist, my career brought me here, and I was hired onto the faculty here about 8 years ago. Great university, flagship university in Scotland, a very old university. It was founded back in the 1580s, which, do your math, that's a good 2 centuries, basically, before the U.S. became a country. And believe it or not, it's not even the oldest university in Scotland. There's 2 universities that are older. So Scotland has had universities like Edinburgh for a long time. So it's an amazing thing to work here. So much of the science of geology and paleontology, the early history of those sciences, was done right here in Edinburgh. So it's a privilege to be here. And we have a growing dinosaur and vertebrate paleontology research group here. So for any of you that are listening, uh, maybe one day you can come and study here. Maybe you can do a master's degree here. We have a 1-year master's program. Maybe you can come here for a semester or for a year to study abroad. It's a very popular place, but keep us in mind in Edinburgh. The reason I call the talk The Rise and Fall of the Dinosaurs is because that's the title of this book that I wrote that was published about 3 years ago now. And the book basically is a biography of the dinosaurs. I try to tell the story of the dinosaurs in that book. And that's the story that I'm going to try and tell you today. Now, I just also want to say that we have a children's version, a young reader's version, and this is it. I should have put it in the slides, but this was just published a couple months ago. It's for 8 to 12-year-olds basically, but it's essentially the same story. It's just written in a way that's more accessible to kids, less jargon, shorter chapters. I take out the times I mention us, drinking beer when we're digging up dinosaurs, that kind of thing. But for younger readers, hopefully that'll be interesting too. Anyway, the story in the book, the story I want to tell you is the story of dinosaurs, the story of where they came from, the story of how they became so dominant and big and impressive and scary and fascinating, and then how they went extinct, or at least how most of them went extinct. And this is a story that is about 160 million years long. And so I'm going to try to do this in 30 minutes or so we have time for questions. So I'm going to breeze through it, and that means probably no more small talk. So let's dive into it. And the story starts way back about 250 million years ago, when the world looked like this. Very different from today, obviously. This was the time of the supercontinent, the time of Pangea. All of the land in the world was globbed together into this one landmass that spread from North Pole to South Pole, surrounded by one giant ocean. And we would have been both, here in Scotland and back in Illinois, would have been kind of in the middle of that supercontinent. And that was a very tough place to live. You were a long way from the nearest ocean. There were vast deserts that covered much of that land, but there were certain plants and animals that were well adapted to that world, including some of our early relatives, some of the very earliest relatives of mammals. They were actually the dominant animals on this world. But then this world was thrown into chaos about 250 million years ago because these giant volcanoes started to erupt in what is now Siberia in Russia. And these are not normal volcanoes I'm talking about. These are not the Hawaiian volcanoes or Mount St. Helens that releases a bunch of ash, or some of the volcanoes like the Hawaiian volcanoes or those in other parts of the world that release a little bit of lava. These were super mega volcanoes, let's call them. These were basically holes in the earth, canyons in the earth that gushed out lava for hundreds of thousands to even millions of years. And that lava covered a land area that was larger than all of Western Europe put together. So if you were living in that area, you would have been in real trouble. But actually, everything was in trouble, because up with that lava from the deep earth came a lot of carbon dioxide and methane and these nasty poisonous greenhouse gases that polluted the atmosphere, led to runaway global warming, and that caused a mass extinction where about 95% of all species died out. The closest life has ever come to completely being extinguished. But it wasn't totally extinguished. There were some survivors. And when I was a student, I became obsessed with this extinction. I wanted to know what lived and what died, and why did the survivors survive, and how long did it take to recover afterwards. So I started to go to Poland, and Poland might not seem like a place that fits the stereotype you might see on the Discovery Channel or Nat Geo, where people go and dig up fossils. You see that stereotype of people going out to the desert where it's hot and dry and they're brushing sand off of the bones, that kind of stuff. That does happen. You can find dinosaurs in those places, but actually, you can find dinosaurs anywhere where there is rock of the right age and the right type that might have bones inside of it. And so Poland has rocks that were formed during and after that great extinction. And these rocks are exposed in quarries where they mine clay to make bricks. And you can read the layers of those rocks like the pages in a book to see what happened across that extinction and then how things recovered afterwards. What we see is almost right after those volcanoes stopped erupting, we see these fossils. Now, these might not look super impressive. I'll give you that. You know, this is not a complete skeleton. It's not sharp teeth and claws and lots of bones. This is a different type of fossil. This is what we call trace fossils. These are marks that were left behind by an animal. And we have a handprint here and we have a footprint here. And this is actually part of a trackway. It's part of a trackway that was made by an animal that looked like this. We know this because there are skeletons that match the footprints, kind of a Cinderella situation from other parts of the world. But these are the very, very oldest, these tracks from Poland. This animal was just about the size of a house cat. You could have held it in your arms. It was kind of awkward looking. Long, gangly arms and limbs, kind of like one of those little Italian greyhound dogs, really fast little dogs. And this thing would have been really fast too. Believe it or not, this is where the dinosaurs came from. It doesn't look like T-Rex, it doesn't look like Brontosaurus, but all great things have to start somewhere. And it was these types of animals, these things that survived and then proliferated after the extinction, that were the forebears of the dinosaurs. But they were not dominant animals. They were not huge animals. They were not at the top of the food chain, and they would not be for quite some time. We've done a lot of fieldwork also in southern Portugal. Maybe this looks a little bit more like that Discovery Channel stereotype. It is pretty hot and dry, and we're here in these small hills in southern Portugal, digging up bones from this red rock, which comes from this first interval of dinosaur history after that bad extinction. And this is called the Triassic period. That's the same age as those rocks in Poland. We do not have footprints here, but we have bones. Yes, we have bones. We have lots of bones. We actually have a graveyard, essentially. We have a what we call a bone bed, where we have dozens, probably even hundreds of skeletons, if we dug them all up, of a Triassic animal. The types of animals that ruled the rivers and the lakes and the shallow water and the nearshore environments at that time. But these were not dinosaurs. Those first dinosaurs were too small, too humble. These animals we have in Portugal are these things. They are salamanders the size of small cars. These were the dominant animals in and near the water. So if you were one of those small little cat-sized early dinosaurs, you would have stayed away from the water. These things were there waiting for you. But dry land was no better, because the Triassic period was the age of crocodiles. Crocs and their close extinct cousins were the dominant animals on land. There were so many species, many more species than the dinosaurs, and they had a just bewildering variety of shape and size and diet and behavior. You had some crocs that were nearly the size of buses. You had others that had spikes and armor all over their bodies. You had some that ate plants. Others were apex predators at the top of the food chain. Some, like that one in the middle, had a sail on its back and even lost its teeth, and its head had a beak on it. And that's just a small snapshot of the diversity of the crocs during the Triassic. This was their time. They were the dominant ones, and their cousins, the dinosaurs, were not very impressive. But that changed. And we know that changed because crocs, there's not many of them left today. And we know that dinosaurs went on to do great things. So what happened? Well, about 200 million years ago, so that's a good 50 million years after those first little dinosaur precursors were leaving their footprints in Poland. So 200 million years ago, this world of the supercontinent changed, and the supercontinent started to break apart. And obviously it did, or else we wouldn't have separate continents today. So this is why we have separate continents today. So that supercontinent, it didn't just crack like an egg all at once, but it started to unzip down its middle. And North America separated from Europe and Asia. South America separated from Africa. That's why they fit together like puzzle pieces. Now, today, the Atlantic Ocean fills that gap where the land split apart. But before water rushed in to fill it, the earth once again bled lava. This was another time of those super mega volcanoes. And these erupted for a few 100,000 years. And they caused global warming again, and they led to another mass extinction. It wasn't quite as bad as that one 50 million years earlier, but it was still one of the biggest die-offs in Earth history. Lots of stuff died. Those giant salamanders basically all gone. The crocs, they were decimated. They were among the great victims of that extinction. Not all crocs, there were a few species that survived, and they were the ones that led to today's crocs. But all of those giant crocs and the big apex predators and the ones with the plant-eating crocs and the ones with the beaks and all those, they died out. They were the victims of that extinction. The survivors, the success stories, the ones that endured all of that destruction were the dinosaurs. The dinosaurs sailed right through. They barely felt the pain of extinction. And we don't know why. I don't know why. Nobody knows why. There's lots of ideas. Maybe they grew faster. Maybe they could run faster. Maybe they could hide easier. Maybe they were smarter. But we don't know for sure. All we know is that the dinosaurs did survive, whereas the crocs and the big salamanders, their competitors, were nearly wiped out. So the reason why this awaits the discovery from a new generation of paleontologists. I think it's the biggest mystery about dinosaur evolution that's still out there. But regardless of the answer, what's clear is that as the Triassic period ended with that extinction, a new world was born, and that was the world of the Jurassic period. And there's a reason it's called Jurassic Park, because if it was Triassic Park, it'd be a bunch of crocs and giant salamanders. Pretty cool, but not a movie about dinosaurs. But the Jurassic is when we get into the age of dinosaur dominance. This is when dinosaurs spread around the world. This is when dinosaurs start to evolve into enormous sizes, some as big as Boeing 737 airplane. This is when dinosaurs, the meat eaters, get to be as big as buses and start to top the food chain. And this is when we see all kinds of familiar dinosaurs with plates and spikes and frills and duckbills and dome heads and so on evolve and start to proliferate. Now, right now, we are in the middle of a golden age of paleontology, a golden age of discovery, at least until COVID shut down a lot of field work, which has been challenging. It's been 2 years since I've been in the field now, which is, it's really hard to want to scratch that itch to go out and find new dinosaurs, but hopefully before too long. But at least before COVID put a lot of stuff on hold, somebody somewhere around the world was discovering a totally new species of dinosaur on average once every single week. So there were about 50 new species being found every year. And we now have over 1,500 species of dinosaurs, but there were probably much more. Much, much more. There were probably millions of dinosaurs at once. So there are still lots of dinosaurs to be found. For any of you who are young and interested in paleontology, do not think that we have found all the dinosaurs. But do think that we are still finding more dinosaurs than ever before, and that is because the field has really diversified, it's really opened up. Paleontology, let's face it, used to be a pretty specialist, really niche research discipline. It was the kind of thing you could really only study at some of the more posh universities, let's say, in the US and Canada and in Britain and in Western Europe. But now, most of the new discoveries are being made in China, Brazil, Argentina, South Africa, these enormous countries that are growing, training new generations of homegrown scientists, not just little boys anymore. A lot of little girls go into paleontology too. So that's what's behind all these new discoveries, and it's not slowing down. And it won't slow down. COVID won't make it slow down. We will get back to it soon. People are finding so many new dinosaurs these days. They're finding them all over the world that we're even finding them right here in Scotland. And this is not a place I don't think that you think of when you think of dinosaurs, maybe you think of the Loch Ness monster and that story, but you're probably not thinking of dinosaurs because Scotland does not fit that stereotype you see on TV of where people find dinosaur bones. But there is one place in Scotland where we can find dinosaurs, and that is this gorgeous island off the west coast, and this is called the Isle of Skye. And it looks like a fantasy scene out of Lord of the Rings or something like that. It is a beautiful, striking landscape, an amazing place to work. And luckily for us, among all of this beauty, which by the way is where many Hollywood blockbusters have been filmed, Transformers and other shows like that recently, because of the beauty there. But among this beauty is rock from the Jurassic period. Some of those cliffs are sculpted out of that rock, and there are dinosaurs in that rock. Now we go to Skye. We try at least about once a year or so to dig up dinosaurs. It's a challenging place to work. I mean, this is May, and we are in our heavy coats and in our caps. It's. I mean, if you couldn't see the background there, you might be forgiven thinking that this is a Chicago winter. Not quite that bad, but it's cold. It's always damp there. It's windy, and we're always dealing with the tides, coming in and out because a lot of the rocks with the fossils are along the coast. It is a great place to take students. We bring our students there. We use Skye as a bit of a laboratory to teach our students how to find fossils and how to dig those fossils up. And I'm not exaggerating or telling a fib or anything when I say that it's the students that always find the best fossils. In fact, I wish I could take the credit personally for a lot of the good fossils, but no, the students always find the best stuff. The best example here in the middle is Amelia, who was a student a few years ago, and she's pointing at something where that ruler is next to, and that is the head of a pterodactyl, and is connected to a body, to a skeleton. This is one of the best pterodactyl skeletons that's ever been found here in the UK and really globally, and we're studying it right now. So keep your eyes tuned. Later this year, maybe we'll announce it. But pterodactyls are not dinosaurs. They're mistaken for dinosaurs quite a lot, but they're cousins of dinosaurs. So I won't say any more, but I'll just say, students find great stuff. Here's one of our students, Moji, who came from Nigeria to study with us in our master's course. Moji was studying the fossil fish that lived alongside the dinosaurs, kind of in the tidal zone, when the dinosaurs are on land. And she's using an angle grinder here. The rock is really hard, so you're not using your hammers and chisels like you might see on TV. You're literally cutting the bones out of the rock. That's okay for fish, a little tool like this. When it comes for dinosaurs, you need much bigger tools. And this is our friend Doogie, who grew up on the island. He started his own museum. He built it himself out of the ruins of a 19th century schoolhouse. And he's a builder by trade, so he has some very nice diamond tip saws. He knows how to use them, and there he is taking a dinosaur bone out of the rock. Okay, I could go on forever about Scottish dinosaurs and working on Skye, but I want to tell you one story that illustrates why Skye is important, what it tells us about dinosaur evolution. And this is, at least until Amelia found that pterodactyl, was, I think, our most important discovery. And we found it here. This is at the far northeastern tip of the island. I'm taking this picture standing in the shadows of the ruins of a 14th century castle. So very Scottish scene. And it's a rare sunny day in Scotland. Look at that. So you might be asking, why am I taking this picture when the sun is out? Shouldn't I be looking for fossils, taking advantage of the weather? Well, no, because we can't, because it's high tide. So the waves are lapping up against the beach, but at low tide, that beach turns into a rock platform. That is Jurassic age rock. We went out there to look for fossils. We were really enthusiastic. We spent all day looking at this site on our hands and our knees. We found a few fish bones for Moji, but no dinosaurs, and we were really disappointed. We thought there was great potential at this site. So we started walking back to our vehicles around dinner time, and we started to notice these tide pools, these holes in the rock platform where there's seaweed in there and hermit crabs and that kind of stuff. And these things were big. They were about the size of car tires. And we then noticed that, whoa, wait a minute, there were actually over 100 of these holes on the rock platform. We just hadn't really noticed them earlier because you kind of always see tidal pools. But these ones were different because there was some regularity to them. They were all about the same size, and there was a bit of a pattern, a zigzag, a left, right, zigzagging pattern. And we could see some of these from the side, and we can see that these things were actually impressed into the rock. They must have been made by something putting force on the sand before it turned into rock. Some of them were filled with a harder material that made their shape show in relief. And we could see that they had bits sticking out, 1, 2, 3, 4 bits right there. We could see often they were paired together, a bigger horseshoe shaped one, a smaller crescent shaped one in front. And they were big, again, the size of car tires. So after a few minutes, it dawned on us that actually this was a great day. No, we did not find any dinosaur skeletons, but we did find dinosaurs. These are dinosaur fossils, and they are footprints and handprints, but so much bigger than those ones from Poland because we're now in the Jurassic period. Dinosaurs aren't small and humble anymore. They are big giants ruling the world. And there's only one type of dinosaur, really only one type of animal, period, that has ever lived on land in the entire history of the earth that was so big that it left a hole the size of a car tire every time its hand or foot hit the ground. And we are talking about these dinosaurs, the giant long neck dinosaurs, what we call the sauropod dinosaurs, basically the Brontosaurus, Brachiosaurus group of dinosaurs. Now, they were living about 170 million years ago in the Jurassic of Scotland, and these were some of the first truly giant dinosaurs that ever lived. We keep finding more footprints and handprints when we go to Skye. And one of my students, Paige, who is from the US like me, but she moved out to Scotland to study with us, she has been studying a lot of these footprints. And Paige has both a geology background, so she studies rocks and she's an expert on rocks, but she also has an engineering background. So she's really good at building machines and equipment and tools and running experiments. And so Paige has used drones and other photographic equipment, some she built herself, to map all of these track sites. And this is important because it can tell us how many footprints we have and how many handprints and which ones form trackways. And you can tell how big the dinosaurs were from the size of their tracks and how fast they were moving based on the spacing between the tracks. And you can tell the environment they were making the tracks in based on the rocks they're found in. And what that tells us was that this is what Scotland was like in the Jurassic period. Here's one of these giant long-necked dinosaurs, actually two of them there, going out, wading into the shallow water of a lagoon. That's the rock the footprints are found in, lagoon rock, after a storm to look for food. And as you can see, though, there's another type of dinosaur in the foreground. We have footprints of this dinosaur too, but only footprints because it only walked on its hind legs. It was just about the size of a human. And believe it or not, this is a primitive tyrannosaur. This is one of the evolutionary ancestors of T. rex. It lived 100 million years before T. rex. And obviously, it was much smaller than T. rex. But remember, great things, big things, powerful things, dominant things have to start somewhere. This is where T. rex started. Now, in Scotland, we just have a few footprints. We have a few little bits of bone, but there are much better skeletons from China of about the same age. And these tell us that these primitive tyrannosaurs looked like this. Again, just about my size. That's how tyrannosaurs started. Now, obviously, over the next 100 million years that they lived, tyrannosaurs got a lot bigger. These dinosaurs, the primitive tyrannosaurs, were not at the top of the food chain. They were 2 or 3 rungs down on the food chain. They lived in the fear of other giant dinosaurs. But later on, the tyrannosaurs would take that crown for themselves. And how did that happen? Well, we have a new species of tyrannosaur from another place that you might find interesting. And this is from Uzbekistan, another example of how people are finding dinosaurs all over the world. And this is one that I studied and named a few years ago with colleagues of mine. We called it Timurlengia. That's named after a warlord from Central Asia, because this thing wasn't a warlord. It was at its time. It was intermediate in size between those first small tyrannosaurs and the last giant ones like T Rex. It was about the size of a horse, but a very fierce animal. And it helps us understand how tyrannosaurs went from small to big. And how did that happen? Well, this thing here on the screen to the left is the back end of the head of this tyrannosaur. That hole is where the spinal cord goes into the brain cavity. We can put that fossil, and we did put that fossil, into a CAT scanner and use the x-rays to see inside of it, and use software to build digital models of the brain, the ears, the sinuses, the nerves, the blood vessels, all of this stuff that you can't see from the outside, that's hidden in the skull. This is what the back end of the brain looked like in blue. This is a big brain for a horse-sized reptile. That tells us these tyrannosaurs were getting smart while they were still relatively small. That thing that looks like a pretzel is the inner ear, and the bit hanging down from the pretzel is the cochlea, and the cochlea is the part of the ear that hears sound. That is a very long cochlea. And we know from modern animals that the longer the cochlea, the greater the range of sounds you can hear. This dinosaur could hear a great range of sounds. So it was smart, and it had keen senses. And it was probably developing intelligence and keen senses in order to live underfoot and survive when there were other predators lurking about. But then some of those other predators died. They died out. Another mystery, we don't quite know why. This happened in the Cretaceous period about 90 million years ago. There probably was a bit of climate or environmental change, but they died out. But the tyrannosaurs survived, maybe because they were smart and had good senses. And it was from those survivors that they now took over those niches at the top of the food chain, and that's where T-Rex came from. To me, my favorite dinosaur, the greatest dinosaur of them all, the size of a bus, 40 feet long, weighed 7 or 8 tons, had a head the size of a bathtub, it had more than 50 teeth. Each one was the size and shape of a banana. It could bite so hard with those teeth that it crushed the bones of its prey. It literally crushed right through the bones. We have shattered bones of its prey species like Triceratops, the ultimate dinosaur. But while tyrannosaurs were getting bigger over time, another group of meat-eating dinosaurs was doing the opposite. They were getting smaller. And these were the raptor dinosaurs. This is the real velociraptor. You probably know Velociraptor from Jurassic Park. It does not look like this. It's green. It is covered in scales. It looks like an overgrown crocodile or lizard. The real Velociraptor was only about the size of a poodle, a miniature poodle. And it was covered in feathers, and it even had wings. And I'm very happy to say, as some of you may have seen, if you're a particular dinosaur fan, that it's just been announced that in the next Jurassic World movie, the raptors and some other dinosaurs will be getting feathers. And it's a long time coming. And I'm very proud to say that I was part of the team that did that. So I'm the paleontology consultant for the Jurassic Park franchise. And so I've known this for a while. I've had to keep it secret, but I can finally talk about it. You're going to see feathered dinosaurs in the next Jurassic World next summer. This is not guesswork. This is not some crazy hallucination or some crazy artistic license by a mad artist. These dinosaurs had feathers. We know that. We know that from actual fossils. We have fossilized feathers. These fossils come mostly from northeastern China. They were found initially in the mid-1990s, about 3 years after the first Jurassic Park came out. So Steven Spielberg did not know dinosaurs had feathers. They're found in this place called Liaoning. It's way tucked up in northeastern China. It has a long border with North Korea. It's a land of factories and a land of farms. And it was in the mid-90s that farmers out plowing their fields, working their land, started to find these kind of things in the rock, these gorgeously preserved skeletons of dinosaurs covered in feathers. And we now have thousands of these. There are so many of them because they were killed basically at once by a volcano that erupted and buried them, kind of like Pompeii, the people at Pompeii that were overwhelmed by Mount Vesuvius. And they basically died, these dinosaurs going about their everyday business. And they were buried so quickly in that volcanic ash that the feathers did not decay away. They didn't have time. They were locked in place. They were locked in stone. I've been able to study a lot of these dinosaurs. It's been a huge privilege to go to Chinese museums, work with Chinese scientists, and see the latest cache of fossils that farmers have brought in. These are really important fossils. They tell us a lot of things. First of all, they tell us that lots of dinosaurs, maybe even all dinosaurs, had some type of feather on their body. These are two tailbones of a primitive tyrannosaur, one of those small early tyrannosaurs. These things up here that look kind of like scratches in the rocks, those are feathers, but simple feathers. They look more like hair. These are the types of feathers that most dinosaurs had. We have them on meat eaters and plant eaters. We have them on lots of different dinosaurs, small ones, even ones, dinosaurs that are up to like a ton and nearly as big as long as a bus. Obviously, these dinosaurs could not fly with these feathers any more than we can fly with our hair. So feathers did not evolve for flying, but probably to help keep these dinosaurs warm. Same reason hair evolved in mammals. Now, most dinosaurs kept these simple feathers, but one group of dinosaurs modified those feathers, and these were the raptors. And as their bodies were getting smaller and smaller, these feathers got more and more packed across their bodies, especially on the arms. And the ones on the arms got longer, and they got lined up across the arm, and they started to branch out, and they started to get flat, until they took on the shape of those classic quill pen feathers that make up the wings of birds today. This is a wing, a fossil wing. Look at all those feathers anchored to the forearm and to the hand, just like in birds, size, shape, arrangement, just like in birds. But this is not a bird. This is a raptor dinosaur. It is this dinosaur. And here I am with my pal Jun Chong from China. We studied this dinosaur. We named it a few years ago, Zhenwan Long, we called it. There it is, beautiful fossil, chocolate brown bones, feathers all over its body, feathers on the tail, feathers up over the chest, over the head, and there's one wing, there's the other wing, there's that bit I showed in the picture before. This is a winged raptor dinosaur, but it's about the size of a really big dog, like a St. Bernard or something like that. It is too big to fly with wings that are that small. This is what it would have looked like in real life, something like this. If you saw this alive, I think you would have just considered it a bird, a weird bird, a very scary bird, but probably not any weirder than a turkey or an ostrich or an emu. But we don't call it a bird because it could not fly. That means wings evolved for other reasons too. Wings did not evolve for flying, but probably as advertising billboards sticking out of the arms of these animals to attract mates and intimidate rivals, kind of what a peacock does with its tail. But you can imagine that evolution, if it made an animal like it had an animal like this, and it made it a little bit smaller and made those wings a little bit bigger, you could get an animal that could flap those wings and generate some lift and some thrust and keep itself up in the air. And it's at that point that we say birds were born. Birds had evolved. They had evolved from dinosaurs, which means birds are dinosaurs. And today's birds are dinosaurs. And there are still dinosaurs with us. Now, I know it's a weird idea. And a lot of people sometimes, will say things like, well, yeah, maybe birds evolved from dinosaurs, but they're so different from T-Rex and Brontosaurus and Triceratops that we should not call them dinosaurs. But the obvious answer to that is this. This is a bat. Of course it's a bat. It's a mammal. Of course it's a mammal. It has hair. It feeds its young milk and so many other things that we know are only in mammals. A bat just so happens to be a strange type of mammal that got small, evolved wings, and developed the ability to fly. And birds are the dinosaur equivalent of that. They are a peculiar type of dinosaur that got small, evolved wings, and developed the ability to fly. We consider bats mammals because they are mammals. They evolved from other mammals. They have characteristic features of mammals. So we got to consider birds to be dinosaurs. That means there are over 10,000 species of dinosaurs still with us, some majestic, like our bald eagles, others not so much. When you see these seagulls at the beach, diving down, trying to steal your French fries, trying to take a bite of your ice cream, it's annoying. It can be kind of scary. And I think in those moments, you can sense the agility, the nastiness, the cunning, the feistiness. You can sense the inner velociraptor in a seagull. And that's true. They evolved from dinosaurs. And velociraptor is actually one of the closest cousins of birds. So dinosaurs live on today. But of course, only one type of dinosaur, the birds, because 66 million years ago, the continents had continued to move. We're now at the end of the Cretaceous period, time after the Jurassic. The world's looking like this. It's looking more modern. There are dinosaurs living on all of these land masses. But this 6-mile wide asteroid fell out of the sky one day. It was traveling faster than a speeding bullet. Literally, it was. And it smashed into the Earth with the force of over 1 billion nuclear bombs put together. And it punched a hole in the crust over 100 miles wide. That crater can now be seen in Mexico near Cancun. That's where it is. And the dinosaurs were there. T-Rex was there. Triceratops was there. There were plenty of dinosaurs that were alive that day, that were thriving, that were still on top of the world. But they could not cope with everything that came from that asteroid. Wildfires, tsunamis, earthquakes, hurricane force wind, all the dust going into the atmosphere, blocking out the sun, causing a global nuclear winter. Plants couldn't make their own food. Forests collapsed. Plant-eating animals didn't have anything to eat. They died. The meat eaters didn't have anything to eat. They died. The food chains collapsed. And all dinosaurs, except for a few birds, only a few birds, made it through. So now a lot of my research is turning attention to what happened after the extinction. And so I find myself a lot in New Mexico. This does look like paleontology on TV. This is the desert. It's dry. It's dusty. There's lots of fossils out there. And I bring my students out there. And already some of my students I've trained, like Sarah here, who was my very first PhD student, they have become world experts in the animals that took over from the dinosaurs. And we find thousands of their fossils in New Mexico. A lot of their fossils look like this. And these things might look familiar to you because all of you, or at least most of us, have these very things in our mouths right now. These are teeth, and these are the characteristic molar teeth of mammals. These are not the steak knife teeth of T-Rex. These are our teeth. And so it was mammals that survived the extinction and took over from the dinosaurs and now really rule the world. And there was even one type of mammal we find in New Mexico, not too long after the extinction. It was about the size of a house cat. It had long, gangly arms and limbs, but it had these opposable digits. It could grasp onto the branches. It was a tree climber. And this thing is called Torohonia. It's a Navajo word for where it was found. This is one of the very earliest primates. This is an ancestor of ours. And that shows that this whole story is connected. The dinosaurs are connected to us. If that dinosaur extinction didn't happen, we would probably not be here having this conversation. And so this is where a lot of my research is going. This is where the next book is going. Next summer, I'll have a book out, a follow-up to The Rise and Fall of the Dinosaurs, and it will be all about mammals. So that'll be a lot of fun, and maybe I'll be able to speak to you all about that in the future. But for the moment, I will end there and just say thank you for your attention. And I look forward to answering some questions. So please do let me know any questions that you have. So thank you very much.
Yes, if you would like to post questions in the chat, or you can go ahead and unmute yourselves at this point. We would love to hear from all of you.
anything that's on your mind about dinosaurs,
Um,
while I'm here, I'm happy to answer. I can't give away plot lines for the new Jurassic World movie, I'm sorry to say, but everything else is a fair game.
could you talk about how the birds breathe? I did
Mhm.
read the book, and I didn't understand about how the birds breathed. They
Yeah.
have extra sacs in the
Yep.
bowl. That
Yep.
seems
Yep.
really bizarre.
Yep. It's a great question because it's hard to grasp how birds breathe because they breathe so differently than we do. And dinosaurs, by the way, at least most dinosaurs had the same lung as birds. We can tell from the marks that it left on the bone. When we breathe in and out, and we have kind of a cul-de-sac in our lungs. In, out. What birds have is they have their lungs, but those lungs are connected to a bunch of air sacs, basically balloons, a bunch of balloons that stick out from the lungs. When a bird breathes air in, some of that air goes across the lungs, and that air has oxygen, just like when we breathe in. Some of the air that a bird breathes in does not go across the lungs right away, but it's shunted off to those air sacs. And those air sacs inflate. And then when the bird breathes out, those air sacs deflate, and that air, which still has oxygen, goes across the lungs, which means that birds take in oxygen when they breathe in and when they breathe out. We don't. We only take in oxygen when we breathe in. So basically, they have twice the breathing power as we do. This is why, for instance, you have some birds that live in the Himalayas that fly over the top of Mount Everest. If we're in an airplane at that same altitude, we need a pressurized cabin. Our lungs cannot find enough oxygen there. So a lot of dinosaurs had those lungs. We know that because those air sacs leave marks on the bones. They often invade into the bones, and they leave a telltale sign. So really remarkable. One of the great superpowers of birds. It helps them fly. It helps them take in enough oxygen they need to fly. But it was really the dinosaurs that evolved those lungs first. And now hopefully that answered. It's a weird
Thank you.
engineering thing. It's so hard to grasp because it's so different from what we're used to. And I see there's a couple of questions here. So Mike's asking, why did I choose paleontology? So when I came to it when I was in high school, I was not one of those really young kindergartners, preschoolers that knows all the names. That was not me. But it was my brother, and my brother Chris. Uh, his bedroom was a dinosaur museum. He had every Jurassic Park toy. He had hundreds of dinosaur books, and so it was really through him. He got me interested over many years, kind of wearing me down gradually. When I went to high school, I became really interested in dinosaurs, and I started to read a lot about them. I started to drag my family to museums, to the Field Museum all the time, as much as we could. And I had a great teacher in high school as well. We had a geology class at Ottawa High School, kind of unusual because it's not a huge high school, and geology is a little bit of a niche science. But my teacher, Mr. Jacobchek, was a great teacher. He took me out. He showed me how to find fossils. When I started to find my own fossils, that was just intoxicating. Finding things, you're the first person to ever see them. These things are millions of years old, from distant pasts, long before humans. And so, by the time I was a couple years in high school, I knew I needed to do this as a career. And so then I went to school in Chicago, went to college, studied geology, started to work in the lab of a very famous paleontologist who also grew up in the suburbs, Paul Sereno. He's from Naperville. And so I learned a lot through him. He took me on my first dinosaur digs because you can't find dinosaurs in Illinois. At least nobody has yet. There's a tiny bit of Cretaceous rock at the southern tip of the state. So someday somebody will. And I would love to be that person. That's like one of the all-time dreams. But since I don't live there anymore. But that was really my route there. And then I came over here. Just when you're a researcher, you never know where the winds are going to take you. There's a limited number of jobs, limited number of universities, so you never know where you end up. And then Leanna's asked about the book for children available now? Yes, it is. It came out in March, I believe. Yeah, so it is available.
And we do have copies of both books available physically at the library. And if you're someone who uses Libby Overdrive, we have the ebooks and e-audiobooks available as well.
Excellent. So please read the books.
Yes, the link in the chat is to our catalog for those. So.
Awesome. And thanks for, it's just always really special. And I figured you would have the books, or else you wouldn't have invited me. But whenever I hear a library has the books, that's just always so neat because, when my brother really became obsessed with dinosaurs as a kid, I mean, every week when we went to the library, my mother would take us every week. He would check out dinosaur books. Every book he checked out each book probably 50 times. So many people learn and really start reading through libraries. So it's super cool that you have the books. What else are people thinking? I think we have a few minutes left. Any questions? Happy to answer anything about dinosaurs. And for those who might be listening to the recording, if you're listening to this and you obviously don't have a chance to ask a question, but I'm pretty easy to find online on Twitter or just my email. So drop me a line. Feel free if you have a question, whether it's about the books or whether it's just about dinosaurs in general.
I am going to ask a more scientific question because this is something I read about at one point, which had to do with you talk in your book about how dinosaurs were able to grow so big, and it's related to something special about their bones. Is that right?
Yep. So this is one of those, all-time great questions. And why were things like Brontosaurus able to get so huge? Especially when today's mammals on land are not able to get that big. Now, the biggest whales are bigger than the biggest dinosaurs, but that's because the ocean's just a different world. You don't have to hoist yourself up against gravity. You can kind of float in the buoyancy and all that. But on land, the biggest mammals have never come close to the biggest dinosaurs. It seems like there's a handful of reasons for that. And I just see that, in the chat, somebody put was because of the larger amount of oxygen at the time. No, you may have seen that though. That's mentioned in a lot of books, especially older books and the books that I had as a kid that I remember from school. That used to be the thought. There was not more oxygen in the atmosphere back then. It was more or less the same as today. But you might remember from a couple minutes ago that dinosaurs had a way to take more oxygen from the air than mammals. And so those lungs were probably a big part of the story, in addition to a few other things that worked together in tandem. So the long necks, these dinosaurs could reach high into the trees. They had a never-ending buffet of food that no other dinosaurs could reach. So they could eat and eat and eat, and they grew pretty fast and so on. So it was, and those air sacs also lighten their bones. So it's not like they were having to hoist around, rock solid bones. It was like a really well-constructed skyscraper. And those air sacs would have been an air conditioning system. So they helped keep the dinosaurs cool. So all that stuff worked together to allow dinosaurs to get big. It gave them that potential. I see there's a question about what my favorite dinosaur is. I'm pretty cliched there. It's T-Rex. I mean, I wish I could pretend otherwise and give you the name of some super obscure dinosaur that only a paleontologist would know. But like most 5-year-olds, it's T-Rex. I mean, it's the biggest, baddest, pure predator that's ever lived on land. So, as far as an animal produced by evolution over time, incredible. And the fact that it came from such small ancestors, I think, is a really neat story.
Steve, thank you so much for being here with us today. This was fantastic. I really enjoyed your presentation and how accessible you make it for everyone. I understood 99% of what you said, which is pretty good for a scientist.
Well, that's good. And, thanks all of you guys for tuning in. And again, anybody who's listening in the recording, or if you have other thoughts, other questions, please do drop me a line. And, hopefully maybe this will inspire some of you to read the book. And when the mammal book comes out, maybe that'll be of interest. And of course, I'm sure you're all going to want to see Jurassic World next summer. So have fun with it. But until then, I hope, stay well, stay safe. Hopefully you're all doing okay. Craziness of the last 15 months. So hope it's a nice summer for everybody.
We do have one last minute question.
Yeah, that's a good question about feathers and skin. Yeah, is so rare for feathers to be preserved as fossils that a lot of times we don't have really any evidence, yay or nay, that they were there. We do have examples of feathers and scaly skin being found on the same animal. Look at birds today. Look at a chicken. Look at the feet of that chicken. They're full of scales. If you ever eaten a chicken foot, so you can get scales and feathers on the same animal. Feathers probably evolved from scales, they're a type of modified scale. But for most dinosaurs, we really don't know for sure exactly what feathers or scales they had, unless they were so unfortunate, or for us fortunate, to be, buried by those volcanoes in China. That really was the game changer. That one spectacular place.
All right, I think we can wrap up at this point, and I hope you have a great Saturday, everybody. We're going to look forward to seeing you at the library again soon. All right, thank you, Steve.
Take care, everybody. Stay well. Bye.
I did want to ask, one thing I picked up in your book is that you've been involved in a lot of naming of different dinosaur species. I'm curious, which was your favorite that you got to name?
Well, it's like picking a favorite child or sibling or parent or something. I guess there's two that I would highlight. One being the Pinocchio Rex dinosaur. That's the nickname. That's not the real name. But the real name is Chongosaurus, and and that pays homage to the part of China where it was from. But it's a little bit hard to pronounce, so we thought it needed a nickname. So we called it Pinocchio Rex because it has a long snout. It's like a T-Rex. It's a bit smaller, but its snout, its nose is much longer. Not because it lied all the time, although maybe it did, but because it probably ate smaller and faster prey than T-Rex. So it had those longer jaws to kind of snap up the prey, kind of like the long jaws of a crocodile. So that was a really fun one. That was found by construction workers in southern China, and I was invited to help study it by a friend of mine in China, who we'll see a picture of in the talk. And then another one that was really fun was this little dinosaur called Balur, which I talk about in the book. I talk about both of those dinosaurs in the book. And Balur is from Romania, and its name is an old Romanian term for dragon, which is really cool. So I think the name is really neat. And it's from Transylvania, and it was a little feisty raptor dinosaur with sharp claws. And I think there's just something, for obvious Dracula-related reasons, kind of fun about having that kind of dinosaur in Transylvania in reality 68-ish million years ago.
Yes, that was a really intriguing part for me of the book, was when you were talking about the island that created a very different set of species because of the different environment.
Yeah, that's exactly right. And so back in not the entire time that dinosaurs lived, but back in the Cretaceous period, that last interval of time dinosaurs lived, Europe was not really a continent. The sea level was so high around the world. There were no ice caps. There were no big glaciers or anything at the poles. So all that water that today is locked into ice was in the ocean. So the ocean level was much higher. And a lot of the low-lying areas in the world were flooded, essentially. And Europe is quite low-lying, a lot of Europe. You think of like the Netherlands and Belgium and a lot of the UK and stuff. So the only parts of Europe that were land were like the taller mountains today. So parts of like the Scottish Highlands here, and parts of like the Alps, and parts of the Pyrenees, and the other famous mountain ranges in Europe. But particularly what's now the Carpathian Mountains, and that's this big chain of mountains that goes through Romania. And so it was an island basically then, what is now Romania, and it was about the size of Hispaniola, roughly. So Dominican Republic, Haiti, down in the Caribbean. And so it wasn't a huge island, but it wasn't a tiny island. And a lot of dinosaurs lived there, but they were quite unusual dinosaurs because oftentimes weird stuff happens on islands. You know, evolution just does weird stuff on islands. There's not a lot of space. Sometimes there's not a lot of resources. Sometimes there's no predators on the island, just kind of by dumb luck. You know, they never reach the island, so there's less pressure on plant-eating animals and so on. So a lot of very strange dinosaurs lived on that Romanian island. You had long-necked dinosaurs like the Brontosaurus types of dinosaurs that in other parts of the world were the size of, you know, Boeing 737s. In on the Romanian island, they were like the size of cows, and so there were a lot of dwarfs on that island. And this little dinosaur Belor was one of them.